Okay, hello everyone. We are working on section 11.2 now, area of trapezoids, rhombus, and kites. And let's remember from the last unit that trapezoids are a figure, quadrilateral, that has one set of parallel sides, and we know that these are parallel from the little triangles right there on the sides. So one set of parallel sides and two bases. And so we're going to label these base 1 and base 2. The height of your trapezoid is going to be the perpendicular distance, and this is really important with the height, is that perpendicular. You're always looking for that perpendicular distance between the two bases. Okay, so understanding what a trapezoid looks like is going to help us to figure out the area, and that's what we're working on now, finding the area. Let's go to the next one. So here, area of trapezoid. So this is where the area comes from. When you look at a trapezoid, if I were to make a copy of this trapezoid and flip it over, and that's what I've done here with the dotted line, if I flip it over and turn it around, I'm going to get this figure. I'm going to get this figure here that is a parallelogram. Okay, now we know that in a parallelogram, the area is the base times the height. So let's take a look at, on this parallelogram that we've drawn, what the base is. And my base is, if I add these two together, so my base is base 1 plus base 2 is my base of the whole figure. And then we're still looking for that height. Here's my height. Same height, perpendicular line that goes between the two bases. And so the area of this would be base 1 plus base 2 times the height. But then if we look at this figure, how much of it for the trapezoid were we really wanting? And we were really only wanting the area of this part over here, just half. And so that's how we come up with the formula. The area of a trapezoid is going to be base 1 plus base 2, add your two bases, multiply by the height, and divide by 2. Okay, so let's try this problem here, this example, finding the area of the trapezoid. So we've got the area of this trapezoid, base 1, 6 feet, plus base 2, 8 feet, multiplied by the height, which is 4, and divide by 2. So my area is going to be 6 plus 8, which is 14, times 4, divided by 2. 14 times 4 is 56. And when I divide that by 2, the area here is going to be 28. And then remember that area is a squared unit, so this would be feet squared. Okay, so that is how you find the area of a trapezoid. Now, if we already had the area, we'd plug in the area here and solve for which piece we don't know. If we didn't know the height, we would add the bases together, multiply both sides by 2, and we would be solving for the height at the end. So we can work on one of those later. Now let's look at how we find area of the rhombus and a kite. Important thing to remember here about a rhombus and a kite, and also a square. We can use this formula for a square also, although typically we don't. But if you only knew the diagonals, we could use it for a square, is that they have perpendicular diagonals. So these figures that have perpendicular diagonals, this is going to be a form we're going to want to remember, the formula. Any of these figures then, the formula for that, for area, is diagonal 1 times diagonal 2 divided by 2. So you're going to multiply the length of the two diagonals and then divide that by 2, and that will give you your area. Okay, let's look at a couple examples of that. Hopefully you realize in this first example, in example number 1 here, that we have a kite. I have two sets of consecutive congruent sides, not opposite, consecutive. So here on the right, those two are congruent. And then over here on the left, these two are congruent. Okay, so we have a kite. Remember, I'm just reminding you of some things. These two angles right here, the opposite angles there where the non-congruent sides meet, those are the congruent angles. Okay, so let's take a look at how the area formula works. So if I want the area of the kite, I've got diagonal 1, which is 6 inches, times diagonal 2, which is 14 inches long, and then I'm going to divide by 2. So my area here is 6 times 14, which is 84, and I'm going to divide that by 2. So the area here is 42 inches squared, and we would get inches squared from the inches here, 6 inches times 14 inches. When I multiply those, then that's inches times inches, which is inches squared. Okay, so there's your area for the kite. Now let's look at the area for this figure. Let's do our second example over here. And this figure, I would say, I would go with a rhombus. We know that all 4 sides are the same measure. I don't really know anything about the angles. Remember, in geometry, we don't want to go by what it looks like. So we're going to say this is my rhombus, and I'm going to do the area for the rhombus, diagonal 1. Now pay attention to these figures. Sometimes they're going to do this and only give us part. The 30 meters is only for this first part of the diagonal right here. Missed it. Let's try that again. Right there, the diagonal. So I need to add another 30 to get the bottom part of the diagonal. So the whole diagonal from top to bottom is 60. You're going to add those together. And this one, 40 plus the 40 here, is going to give me 80. And so my area, I'm going to move down a little bit. My area is 60 meters times 80 meters and divide by 2. Okay, so 60 times 80 is 2,400. And then we're going to divide by 2. I'm sorry, this is 4,800. I already divided by 2, didn't I? Let's just go back. $4,800, sorry about that, divided by 2, and so my area is 2,400. And again, meters squared. Don't forget to put your units on these things. Okay, let's look at 11.6, the area of polygons. Remember polygons, many sides, triangle, 3 sides. We don't usually do these. We can do the same formula with that, but we have a specific formula for the triangle and for the square. But starting with the pentagon and on up, hexagon, we want to look at how to find the area of those polygons. We have a formula for that. We're going to figure out how to do that. We're going to look at this regular polygon. If you notice, it has 6 sides, so this is a hexagon. And really important here is vocabulary. Vocabulary. Very important in geometry that you understand the vocabulary and learn the words. So we're going to have a new one here. First of all, the center of this polygon, P, we label that usually with the capital letters. So the center of the circle, we're looking at a polygon that's been inscribed in a circle, as shown here. Help us come up with some of these definitions. The center of the circle, P, is also the center of my polygon. And then the radius of that circle, right here, the radius, is PM. That's also going to be, we're going to look at it as the radius of my polygon, P to M. And that M is also one of the vertices of my hexagon. And then this side over here is also a radius. And so what we get is an isosceles triangle. So let's look at this last term here, the apothem. And that's a really important word for you to learn. Very important to learn and memorize. The apothem. And here this is from P to Q. From P to Q is the apothem. Right there. It is the distance from the center of the polygon to the center of any side of the polygon. And so what that is the height or the altitude of the isosceles triangle that has 2 radii for legs. So this gives me an isosceles triangle right here and here. Those pieces, those sides are the same measure. So I get an isosceles triangle where the apothem is the height of that triangle, the altitude. Remember, perpendicular line from the base up to the vertex, so that's the altitude. Now if you look at a polygon, really what we're looking at is we're going to come up with a formula that gives us the area for the whole polygon. But what we can look at is that this polygon is, we can divide this up into 6 congruent isosceles triangles. There can be 6 isosceles triangles with a radius for the legs of the isosceles triangle and the apothem for each one. Here's another one here. Here's an apothem. That's a perpendicular line from the center to the base. The apothem, that'll be the same distance all the way around. And so let's go to the next slide and I'll show you we come up with a formula. One other vocabulary term here to know, central angle. And the central angle is an angle that is created, if you look in this figure, angle MPN is a central angle. So for a hexagon, we're going to have 6 of those central angles. And we want to figure out what the measure is of that central angle. So we want, let's do that in red. So we want the measure of this angle right here. So we're going to take my whole circle, or all the way around P, and I can do that in green. If we went all the way around, that's 360 degrees, right? And so what we're going to do is take the 360 degrees, that's this one, and I'm going to divide that by the number of sides. And the number of sides is also going to be the same as the number of angles that I'm going to get, central angles. Okay, so 360 divided by the number of sides gives me the number of central, it gives me the degree measure of one of those central angles. Okay, so let's look at, in this figure, this polygon is a hexagon. And so my central angle here, here's my central angle, is going to be 360 degrees divided by 6, which gives me 60 degrees. The apothem is also used then to help us determine the area of this polygon. So we get that this angle right here is 60 degrees, the whole thing. But if you look at that the apothem divides this, let's draw it out here so you see what I'm talking about. I'm going to try to make it exactly the same. So P is here, here's my apothem, and that's Q. Okay, so what we get here, since the sides are the same, this one and this one are exactly the same, the apothem is going to divide my triangle into 2 congruent triangles. So it also, that apothem, divides my 60-degree angle into 2 30-degree angles up here at the top. And so this angle right here is going to be 30 degrees. This one, we know if where Q meets the base, that's 90 degrees, then we know that this angle over here has to be 60 degrees. Okay, so that apothem is going to divide my isosceles triangle into 2 right triangles. And so what we're going to be looking at is one of those right triangles. That's what we're going to be using to solve to get the apothem, or to get half of the length of one side. That's what we're looking for. So this one, in this hexagon, we're going to get 30, 60, 90, but we're going to have other ones, like a pentagon, where we might need to use trig. So here's the formula. Formula for the area of a polygon is area equals the apothem A, little a. So if you look on the formula charts, it's going to be little a, apothem, times the perimeter, and then divide by 2. So think about, the apothem is going to be the exact same length, regardless of which isosceles triangle I'm in. The apothem is the same. And then, so if we look at one of those triangles, let's take a look at one of these triangles right here. Let's put the apothem in red. And so if I find the measure apothem times the base, right, base times height, and divide by 2, I get just one of those isosceles triangles. Well, if I want to add up all of those triangles, what if I did the apothem times all of the bases? Right? Add up all the bases. That's what the perimeter does. Apothem times the perimeter, and then divide by 2. So this takes all of my triangles, however many I have for that particular polygon, and gets me the area with just one formula, rather than having to find the area of one triangle, the isosceles triangle, and then multiply by how many triangles there are. So that's how we're going to use, this is the formula that we're going to end up using. Okay, so let's look at this one. Find the area of the regular polygon with a radius of 8. So remember that the radius, let me first get color, my radius here is 8. Remember that the radius goes to a vertex. So let's go ahead and draw to a vertex. Those are 8. Okay, first step then. First step is to find my central angle. So remember that the central angle, I'll abbreviate that, equals 360 degree around the whole circle, around that whole center point, divided by the number of sides, which in this case is 5. Okay, 360 divided by 5 is going to be 72 degrees. All right. Step 2 is to draw the isosceles triangle using a radius from the center to 2 consecutive vertices. Well, I already did that. I put my 2 lines here from the center to consecutive vertices to give me that isosceles triangle. Now let's draw in the apothem. Okay, there's my apothem, and that's a right triangle right here. That's what we're looking at, the right triangle. Know that my apothem divides the isosceles into 2 right triangles. So what I'm looking at here is this right triangle right there. I get a right triangle where the hypotenuse is 8. That's what I'm looking at. The hypotenuse is 8. Now we can label the sides given, which we labeled this one. The side we have is 8, the hypotenuse, for what we need, and the apothem in one side of the polygon. So what we're looking for is my apothem, which is that piece right there. That's my apothem. And then this is one of my sides right here, right? But this right triangle is only going to give me half of one side. Let's give it an X. Okay, so now we've got to solve for what we don't know. Since my central angle, and that's the whole angle right here, since my central angle is 72 degrees, what I know is when I divide that 72 degrees to get this one right triangle, it gets me that right. Let's move this right triangle out so we know what we're looking at. There's the height, I'm sorry, the hypotenuse. That's the 8, right triangle. This is my apothem, and then we labeled this side X. I'm just redrawing it so we can get a better picture. So now when I divided that central angle into 2, it gives me this angle at the top of my right triangle, and that's going to be 72 divided by 2, which is going to be 36 degrees. Okay, so we get 36 degrees for that angle. Now, remember that if we only know one side, which we do, we only know one side, the 8, and we have a degree measure, we're going to have to use trig. So this is going to be one of the problems that we would use trig on. So let's find X first. Remember that if this is the angle I'm at, 36, the opposite side here is X. And opposite, we want sine of 36 degrees equals the opposite over the hypotenuse, which is 8. So to solve for my X, I'm going to multiply both sides by 8. And in the calculator, I'm going to type in 8 times the sine of 36, and that will give me my X value. Okay, I got 4.7. Okay, so the X value is 4.7. But remember that this is only half of a side. And so if I want a whole side, I have to multiply this by 2. So one side is going to be 4.7 times 2, which is 9.4. One side is 9.4, but remember we're looking for perimeter, so we've got to take all the sides, which there are 5 of them, and to get perimeter, we're going to multiply 9.4 times 5. So that gives me 47. Okay, so that's the perimeter. That's one of the numbers that we need. The other thing we need is the apothem. So let's change colors. That's what we're looking for now, the apothem. So know that to get the apothem, we're still going to use the 36, but this time, this side over here is the adjacent leg, and we have the hypotenuse. So this time we want cosine of 36 equals adjacent over hypotenuse, again multiply by 8, and I'm going to get that. Now this is my apothem. No, and there's no eraser. So we're going to say this is A over 8. And so the A, when I solve for A, multiply both sides by 8, I get 8 times the cosine of 36 degrees is 6.5. Okay, so now we have everything we need to do the area. So my area of the polygon itself is going to be the apothem, 6.5, times the perimeter, 47, and I'm going to divide by 2. Okay, I get 152.75. Okay, so I know a lot of work, but that's how we've got to find them. Apothem and perimeter, and then divide by 2. Okay, let's do one more together, and then you can get started on your worksheet. Find the area of the polygon with a side measure of 12. Okay, so here's the side measure. All of them are 12. So this one actually a little bit easier, isn't it? We already know a side measure. Let's draw in the isosceles triangles, a triangle that we need. Let's put in the apothem. Okay, so remember that we need to find the perimeter, central angle. Let's start with the central angle. The central angle, 360, divided by 12. Sorry, 360 divided by not 12, not the side measure, but how many sides we have. 1, 2, 3, 4, 5, 6, hexagon. It's 360 divided by the number of sides, because remember we're finding the angles, and we're going to get 6 of those isosceles triangles. And so 360 divided by 6 is going to give me a 60-degree central angle. Now remember that the central angle gets cut in half. So this angle is half of the 60, and that's going to be a 30-degree angle then. So what kind of triangles are we going to have in a hexagon? We're going to have a 30, 60, 90. There's my 60-degree. So we're going to get 30, 60, 90-degree triangles. So if I'm solving for this one right triangle here, know that each piece in this is 6. Because the base gets cut in half by that apothem, the height of the isosceles triangle. And so really, the only thing we're looking for here that we need for our formula is A, the apothem. So let's look at across from the 30 is my X. Remember how we label, and let me just draw one. If this is the 30 and this is 60, remember how we label them. Across from the 30 is the X, the smallest side. Across from 60 is the X square root 3 side, and the hypotenuse is 2X. And so across from the 30 is 6. And so the apothem, the A, will be across from 60, which is going to be the x square roots of 3 for this particular problem. And since x is 6, my apothem is going to be 6 square roots of 3. So the apothem is 6 square roots of 3. We're ready to find the area. We've got the apothem and perimeter. We need perimeter. And remember the perimeter, we've got 12 times 6. Okay, I'm not sure where I left off here. Apothem, 6 square roots of 3. It's across from the 30, so that's my 6 square roots of 3 side. Perimeter, 72. 12 times 6, which gives me the 72 for the perimeter. And then we have everything we need to find the area. My area then is the apothem, which is 6 square roots of 3, times the perimeter, and then divide it by 2. So 6 times 72 gives me the 432, and then square root of 3. We can't multiply that through square root of 3 is a different term, so we're just multiplying those leading the whole numbers, and divide that by 2. So the 432 divided by 2 is 216 square roots of 3, and then units squared. Make sure we put units, if they have units listed, that we put units on, and area is always a squared unit. So there's your area of a polygon. Now it's time for you to practice.